All right, hey, how you doing, eighth grade? Mr. Hale. Going to be finished. Keep talking about our idea about sound. We're going to talk more about music and what makes good sound and what makes poor sound. We've already talked about the nature of sound, longitudinal waves, sound speed, Chuck Yeager. We talked about the intensity, amplitude. Remember, intensity and amplitude are the same, and we talked about how to measure it in decibels. We talked about frequency and pitch are the same thing. So when you make a pitch, you're going to have the same frequency, and the Doppler effect. But today we're going to talk more about music. Why do people like music? What makes it better? Music is an amazing thing. All of you guys listen to some sort of music. I haven't heard anybody that doesn't listen to something. Everybody listens. Well, there are 6 parameters that make a good quality of sound when we're trying to do it. Is it loud? For some reason, you guys love it loud. I mean, just boom, 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 boom. Okay, sharpness. Can you hear it, or does it kind of mumble through? Is it rough? Sense of roughness, texture. Miles Davis a lot of times played around with this idea of rough texture when they got to the roughness to try to make some of his jazz music. Fluctuation. Does it fluctuate? Is it always constant, monotone, never changing, or does it fluctuate up and down? Is it intelligible? I mean, some of the music out there, I can't understand a word they say, but some of you guys like it. And then the overall pure tone sensitivity. Do we get the tone of everything just right? A term that Mr. Heinemann hopefully has used with you, and I'm sure he has, is called timbre. I mean, I never pronounce it right. But this idea, let's look at this to get an idea of what it is. Each one is playing the exact same note. Let's say these are all C's, and a tuning fork you play is C. If you look really close, that's a very, very nice C that goes up and down, makes a nice sine wave that goes up and down. Well, a flute has some little innuendos in there. Although it's trying to make that up and down sound, it has a little bit of vibrations because of the way you breathe and the way you blow through. It comes out just a little bit different. Okay? Thus, even though you're playing C on a tuning fork and a flute, they sound a little different. When you're trying to sing, it vibrates differently. Still the same frequency, but has those little innuendos because your vocal cords vibrate, your lungs are a little different in shape as they go up and down. Same thing with the violin and how you pluck the violin and you strum the violin, it vibrates up and down. Each one doing a C, but gives its own quality of sound. That timbre makes it all different. That's why when you put them all together, it makes some beautiful noise if you do it just right. Okay. Now, making music, I'm not going to ask you to do all the different musical instruments. You got a whole bunch of different styles. That's up to Mr. Heinemann to kind of teaching he has gone through the maracas, the bagpipes, the harmonica, the cymbal, about the only thing Brandon knows how to play. Ding, ding, that's about it. Or you can go to Anna's triangle style stuff and the piano and the snare drum and all that stuff. Lots of different ways of making music. But we do want to know when we make music, what's this difference between consonance and dissonance? Unfortunately, I can't get to my pitch pipe, which will help me show it, but consonance, dissonance are related to beats. When I have 2 sounds going together, let's move back up here, and we have these 2 beats. What happens if I have 2 waves? Give me a sec. We're going to pull up something, and we're going to show you something else. I'm going to pull it up. Give it a second to load up. We're going to talk about these beats that are happening. Okay, I'm going to have a really poor drawing. I do understand that. But when I have a beat and I have a sound wave that's coming up and down, right? And I have another sound wave that comes up and down. When I add them together, remember, let's change the color of this. When I add the 2 waves together, when I add these together, I'm going to get a really large and up-down wave, right? Well, let's clear that. Right? What happens if I have 2 waves, right, and another wave that's slightly off? When we add them together, okay, I might get this more vibration sound that comes up. When we hit these little spikes here and here and here, we get these things called beats. So when you're trying to tune a instrument, and let's say you have that pitch pipe that plays a C and you strum your guitar to a C, you can actually hear that pitch, that beat. Our goal is to get that beat down so it doesn't happen. If they're perfectly both at C, you won't hear the beats at all, because they both really match up perfectly where they get this nice up and down. When they don't get that nice up and down, you get this up and down and up and down and up and down, and those beats are what you're trying to not get. Okay, so a person that's a good, or let's say a piano tuner, and they do this by hearing, not by computer instruments. Okay, they can actually hear that beat and get it down perfectly. But there's a very strong training you have to do, and it costs a lot of money to get a really good tuner to tune it. Same thing with a violin and everything. You need somebody that really knows what they're doing. Well, consonance is when you start to hear that beat. When the frequencies are far enough apart, the two C's are far enough apart, you can hear that, and that is the beat. That's consonance. When you have a dissonance, they get close enough together, they start to overlap, and you really don't hear the beat. Okay? So, the other thing is, sound waves also interfere with each other. Okay, sound waves, when you produce them, and let's hear, you have the red, the green, and the orange and the green, one instrument playing one type of sound, another instrument playing another. When they hit each other, they start to interfere. When you're making acoustics and you're trying to get acoustics just right, you want to make your facility just right to make sure all of those sounds match up perfectly. Why in an orchestra do they have the violins on one spot and the clarinets and the trumpets on another spot? They're perfectly planned out that way, so when these instruments and the sounds hit each other just right, you get that beautiful sound. Make them mixed up and put them into different spots, it actually doesn't sound as good. And I'm sorry, getting to a real concert, if you guys have never been into a real musical concert, not talking about, Anna's favorite Justin Bieber style concert, we're talking about, an orchestra. It's just amazing what sounds they can do. If you guys ever get to Carnegie Hall and listen there, amazing acoustics at Carnegie Hall. Okay, so we should know about acoustics and that interference of sound and trying to make sure everything works just right. You should understand about the words consonance and dissonance and what a beat is. Don't worry about the instruments. You definitely want to know what timbre is and these 6 parameters. This is Mr. Hale signing off, KD2 LPM for K2 GSG.